Hi, everyone. I'm Andy Harker, and I'm a Senior Director of Technology Management from Arm's Open Source Software Group. Our topic today at this virtual fireside chat is about porting applications to Arm environments. Unfortunately, I'm being joined by someone who knows all about this topic firsthand. So I'd like to introduce you to my guest, Craig Tashman from LiquidText. How are you, Craig? Good to see you.
Hey, Andy. Thank you. Great to see you, too. Thank you, and to the folks at ARM so much for the opportunity to be here. It's great to be here today to talk to you guys.
Okay, good. So before we talk more about your particular porting journey, Craig, perhaps you could just spend a few minutes explaining LiquidText to the viewers, where the idea for it came from and what makes it unique.
Absolutely. So LiquidText starts with the question of how do computers help us understand the things we have to read at work and at school, right? So we know computers help us find great content. We know computers help us compose great content, but how do they help us understand, right? And so the problem is that in a lot of ways they don't. This is why like 90% of professionals prefer to do their reading at work on paper rather than on computers. And if you think about that for a minute, that's staggering. This sort of understanding what we read that's foundational to our whole society, the technology that we've created has in a lot of ways actually made it worse. So I got my PhD a few years ago from Georgia Tech, trying to understand, one, why was this happening? And two, how can we make it better? So when we studied it, we found that a lot of the reason this was happening is because the way we've approached reading on computers has largely been by trying to imitate the way we do reading on paper. And the problem is you end up inheriting the deficiencies of paper without really inheriting the advantages of paper. And so with LiquidText, we said, let's take a different approach, right? Let's start from first principles of cognition, of reading behavior and reading theory, and create something around what people actually need rather than just what they're used to. And so we built these prototypes. We did lots of human subjects testing. And people started saying, this is great. Where do I get a copy of this? And I said, silly, you don't get a copy of it. This is a research project. At best, it gets me out of grad school. And eventually I realized that was the wrong answer. So when I graduated, we did a little bit of work and started a company after I got out of school. And that became LiquidText. And so rather than trying to describe it, it's much better to show it to you. So
yeah, you brought a video along.
I'd love it if you'd roll our little 3.5-minute demo video.
Let's see the video.
Here's the story. Let's say America's honeybees have suddenly started acting strange. You're a honeybee researcher trying to find out why. We'll start by opening our bee-afflicting disease project in LiquidText, where we've already imported the documents we'll need. We'll start with the journal paper on the new bee-afflicting disease. I'll make a text box saying bee-afflicting disease symptoms. Now I'll take the 3 major symptoms, the bees turn red, they make less honey, and they fly slower, and I'll pull out excerpts of them into my workspace. Now I want to compare the discussion of the slower flight speed to the figure that's referenced several pages later. So I'll just pinch the document to bring the figure and the text side by side. See, LiquidText lets you see the most important things together so you can find connections between them. Now I want to keep track of this chart, so I'll circle it and pull it out to the workspace and connect it to my excerpt. See what I've done here? I've gathered information from different places and organized it freely in my workspace. Now let's see if these symptoms match any known bee ailments. I'll make a text box, related ailments, so I can note what I find. So I'll open a review of several common honeybee disorders. I've already highlighted the symptoms of the disorders, but none of them seem to match bee-afflicting disease. But I want to see the bigger picture, so I'll turn on Highlight View and pinch to bring all the highlights together with as much or as little context as I need. Well, I see one illness about low flight speed and another about a color change and less honey. The first is called tarditis. The second is called rubrum disease. Between them, we can account for all the symptoms we're seeing. Note how LiquidText let me see the important things together, so I could find this connection I otherwise might have missed. Now I'll draw some inklings to connect these to my note. See how ink does more than annotate, but can actually capture relationships. Now I'll expand the document back to normal again. Let's take a look at the first ailment, tarditis. I want to compare it to the second ailment, so I'll hold my finger on tarditis and tap the second ink link with my other finger. Look at that. The document automatically shows me both. This is interesting. I'll pull out the references to these into my workspace. And I'll grab that flight speed chart too. But as I read more carefully, there's a problem. The first ailment is a bacterial infection. The second is a virus. How could the bees possibly catch both at once? Well, this article doesn't say much about rubrum disease. Maybe I should learn more first. So I'll open an article alongside the current paper. So first, I'll pull out that pic of the poor red bee. But now I see something interesting. Both these ailments can be spread by the gray mite. Maybe the gray mite is infecting bees with both diseases at once. This is a crucial connection, so I'll draw an ink link to show it. Look at that, I can even connect documents with live ink links, so I can always retrace this connection later. But could gray mites really be at fault? After doing some searches, I find a short note in a textbook. First, let's pull out the reference since we may need it later. And that's interesting. They mention the gray mite is lethal to crickets. I don't know if that'll help us, but let's search our project for cricket. Okay, the inspection report from one of the afflicted hives mentions crickets. Let's see what it says. Look at that. It says there haven't been any crickets this year. Well, this explains it. The gray mite is infecting bees with tarditis and rubrum disease. We have to publish this right away. So I'll go to Send and export my workspace as a nice linear document I can send to my word processor, where I can write up the final paper. And so we win a Best Paper award, and we save the bees.
Okay, so we've saved the bees.
Indeed. I love that video. And
I didn't tell you I was a beekeeper. That was a pretty good example.
We made this video just
now,
for
one
you,
thing.
Andy.
Oh, thank you. I didn't tell you that. Now, I've just got to jump in with one observation there. One thing that did strike me as I experimented with LiquidText was it's certainly a very visual application. You know, there's lots of visual elements. You know, this thing about being able to squeeze a document together to bring two parts closer together. I mean, from the outset, you know, was that aspect of it going to make it a real challenge from a port perspective?
Absolutely. You know, for some of the context, a lot of the things that make paper and the computers that inherit from paper not the greatest place to do reading is because they tend to be very structurally rigid, right? People need to reorganize information, reconnect things, visualize things in different ways. And paper and computers tend to make that hard. A lot of where LiquidText's power comes from is making that easy. And so we need to have all these very high degree of freedom, highly flexible interactions. And unfortunately, because they're so new and so different, they don't really fit nicely into any of the existing SDKs. And so it makes kind of creating them at all means sort of twisting and turning the SDKs around. And so, yeah, porting is definitely a little tricky.
Okay. Well, I think we'll dig into that a little bit more, but I just wanted to explore the porting journey that you've undertaken. So you've ended up, I know, on ARch64 Windows on the Surface Pro X, but where did you start?
We began on the iPad about 5 years ago, and from there we finally came to Windows and Mac OS desktop this year. And now we finally made the last step in the journey, going to ARM64 on Windows UWP as well.
Okay, so any reason why you took that particular route? Was it just by chance, or?
No, it's a very good question. So like we kind of were talking about, right? A lot of what makes LiquidText so powerful is these very high degree of freedom, very flexible interactions. Now, in order to make these interactions work, we need high degree of freedom, flexible ways of inputting information into the computer for the user interface, right? And one easy way to do that is to use multi-touch, right? People tend to think of multi-touch as kind of good for zooming maps, but otherwise largely a gimmick. But it actually enables some really new interactions and some powerful things. And so this was the approach that we took in grad school. And in 2013-14, when we began engineering the app, the iPad had a truly exceptional touchscreen relative to the industry at the time. And so it made a natural starting point. From there, it took us years to understand our users well enough to create a more holistic interaction model that included both touch as well as pen, as well as mouse, as well as keyboard. Once we had that, we could expand to the desktop. And in doing that, we went to Mac OS, but also very strategically Windows UWP, on Microsoft's UWP platform. And from there, it was an easy one little additional step to come to ARM64 on Windows as well.
Okay, so I guess in a way you've come full circle from ARM on an iPad via x86 and desktop back to ARM on a Surface Pro X.
Yeah, right. It's the circle of life. But one of the things that's been so great about going sort of starting from ARM and coming back to it is LiquidText isn't meant to replicate paper, but it is meant to replace paper for many people. And so we need devices that kind of get the hardware out of the way as much as possible, right? Lightweight, great battery life, high performance, low heat production. And on that front, we've loved ARM.
Okay. So I guess we briefly touched on earlier about the graphics and the GUI complexity, and you also mentioned that you've got touch and gestures in there as well, which adds a particularly additional complexity. I mean, given you're looking for consistency across platforms, I mean, how did you get that consistency?
That's a great question. And the number one way is just to basically hire the best engineers in the world. And I've been incredibly fortunate to work with folks like that. But even with a team of rock stars, it was still a challenge, right? We didn't really so much port LiquidText as we kind of had to recreate a lot of it on the new platforms that we were going to. So for example, on the iPad, we do a lot with Apple's low-level Metal graphics APIs, right? We have our own custom shaders, our own custom graphics pipelines. And we couldn't simply, sort of port that to UWP. We had to rethink what the APIs, what DirectX would allow us to do and recreate things there. But on that front, I'll say that our partners at Microsoft and the PAX team on the Windows engineering teams have been just amazing. They spent so much time with us, working with us so that we could get that world-class performance on Windows as well.
Okay, so graphics aside, I mean, what would you say were the other most challenging parts of that porting journey in terms of getting everything working consistently? And I have to say, it looks pretty consistent to me across a number of platforms, but getting things working across all those platforms.
Yeah, it's a good question. So first of all, consistency was a challenge in terms of user experience, right? Again, it took us years to understand our users well enough to know how we could bring these interactions from touch to pen, to pen and mouse and keyboard in a way that wouldn't compromise the core underlying value of the interactions. And the second challenge, again, was just really from an engineering perspective, right? UWP has a very different programming model than iOS, Objective-C, and Cocoa Touch. And so we had to recreate a lot of the low-level graphics, a lot of the low levels of the graphics system that we had built. And we knew we would have to do that, but we thought that the higher levels, we could kind of just casually move from one platform to the other. And in some cases we could, but in a lot of cases, we had to re-engineer things from the ground up to actually get the performance that we needed.
Okay. So another thing I've picked up on in the thick of all the description you've given me so far, you've mentioned this thing called Microsoft UWP, which seems to be significant. Can you give us a feel for what this is and what it did for you from an application porting perspective?
So UWP is Microsoft's universal Windows platform. It's a cross-platform development API, so that if you write something for Windows 10, it basically just works on any Windows 10 device, whether a PC, whether a HoloLens, whether an Xbox. It's actually derived from Microsoft's COM technology, if we remember that, and it works nicely with managed code. So the idea is, in principle, you get the ease of cross-platform development, but the performance of native code. And as we kind of hinted at, bringing LiquidText from iOS to UWP was not a simple port. It was really recreating the whole app, rewriting every line of code around the programming model and especially the concurrency model that UWP provides.
So I guess in summary then, broadly speaking, if correct me if I'm wrong, if you set out to put your application on UWP and you work within that framework, you can pretty much assume that it's going to work, or at least be very close to working on, either x86 64 or ARch64. And I guess that's a good incentive for developers to give UWP a try, right, from a porting perspective.
Absolutely. What I'll say is it is really impressive how easy it is to go from sort of base UWP to any one of the to any particular platform that UWP runs on, right? So once we were on x64, getting to ARM64 was pretty easy. However, I will caution anyone against this idea of, write once, run anywhere. That never is really true. Like, for example, there are subtle differences between the platforms, and there are subtle bugs that you'll see on, x64 that you don't see on ARM64 or vice versa. So from a QA perspective, you really do need to think of these as two separate products.
I guess it would be dull if it just worked without all those little bits of little tweaks from platform to platform. That makes life interesting. So I guess essentially it's just mapping your journey out in my head. It's you're really supporting three distinct ports, right? You're supporting the iOS port, the macOS environment, and then really UWP as a single environment. So I think my next question is, how much work was involved in switching LiquidText to the UWP platform, and do you find you're able to maintain any common core code which is common across all of these rather three distinct platforms?
That's a great question, and the answer is yes. And in fact, I would say that we built our macOS app using Apple's Catalyst technology, so it actually shares a lot of code with our iPad app. So in a sense, we're not really maintaining three code bases, but or three products from a code perspective, but like 2.5. That said, from a QA perspective, it's definitely four products, right? macOS, iOS, Windows UWP, ARM64, and Windows UWP x64. In terms of a code sharing perspective, absolutely. Like I said, a lot of code shared between our macOS and iOS apps, but UWP shares basically zero with either of them. First of all, our UWP app was written almost entirely in C#, and our macOS and iOS apps are written almost entirely in Objective-C. But again, more than that, the programming model, the concurrency model, there's just so many differences that we really couldn't have shared much code there anyway. Just as one example, right? There's places where in our iPad app, we actually just need such performance in the tightest inner loop that we just go and malloc a big chunk of code and manage it ourselves, because the Objective-C abstractions, fast as they are still too slow for us, right? You can't just, for a lot of reasons, you can't just casually recreate that in UWP. So we had to really think about how their APIs work and how to really recreate this in the way that would get us the best performance.
So old school malloc working still exists. Good to hear. So looking across these three environments, I've played with LiquidText on a number of platforms. Do you think you've had to compromise on, either feature consistency or some aspect of performance in order to make it work?
No, that's a great question, and I would say not really compromise. But we took the time to really understand what our users needed on each platform, and what trade-offs would be necessary, what would be the benefits of different approaches, what were the features they needed, and really recreate it there. And so, for example, there are some features that exist on our iPad app that just don't make sense on the desktop, and likewise, some features on the desktop that just don't make sense on the iPad app.
Okay, so often with these journeys, the unexpected happens. So I've got to ask you, did anything surprise you along the way, such as something being, far easier than you expected, for that first time compilation or whatever, or perhaps something that, you didn't anticipate but turned out to be really unexpectedly challenging?
Yeah, great question. Like I said, nothing ever just works, but UWP came very, very close to that. I was really surprised how easy it was once we were on x64 to just come right across over to ARM64 and UWP. It really was very easy. But on the flip side, there were some challenges as well. One was that many dependencies have actually not been created in a truly cross-platform way, right? So some of the libraries we use either have native dependencies or were just compiled natively. So they wouldn't run properly on ARM64. But here's where I'll say that the teams at ARM, the teams at Microsoft, our own engineering teams, and the different suppliers that we work with were amazing. And again, you guys at ARM and Microsoft were just incredible working with everyone to get some of these some of these libraries ported over in record time. Besides that, UWP is really impressive, right, with what it can do, but that impressive power necessarily involves a certain level of complexity. And so there can be subtle bugs that might appear when you submit an app to the Microsoft Store that you don't really have when you're just doing internal testing. And so this means that you need to, resubmit your app to the Microsoft Store each time you want to do another iteration. And that only takes a few hours, which is incredible. But if you do actually detect any problems there, it is going to certainly increase your cycle time. Not the end of the world, but just something to keep in mind as you do development.
Yeah, I guess that's one of those things that's just going to happen at the very, very tail end as you know you've fixed it and you just want to get it out there, right?
Exactly.
Okay. So, do you think there are any things which would have made life easier for you looking back on the journey if you've had them? I guess I'm sort of asking you in a way for, the Craig top 3 things you'd wished you'd had to start the whole thing in retrospect.
Yeah. And I would say the answer to that is I'll actually give you the top 4. And that's to have a clear understanding that these were 4 distinct products, right? Even if they shared a lot of code, certainly from a QA perspective, testing perspective, these really have to be seen as independent artifacts.
I think that's totally understandable in a way. Certainly, when you've got things like touch on and gestures on one platform and not the other, they're probably just going to work differently. So I guess from a LiquidText perspective, what are the next 1 or 2 things on the backlog for LiquidText? What are we going to see in its next iteration?
We're so excited now. We have LiquidText on all these different platforms, but the one thing that we're missing is the glue to connect them together. And so the big thing that we're working on now is a synchronization, backup, and collaboration service. So we're building our own web service from the ground up, designed to work with LiquidText projects that are even hundreds of megabytes, even gigabytes in size, and still give you really, really great real-time syncing and collaboration between your different users and your different devices. This is the big thing that we're hoping to have out early next year.
So is this going to work across, cloud domains, or is it constrained to a cloud domain? So am I going to be able to do something on platform A and see it on platform B? So common cloud?
Yes. So we're building our own cloud built on top of Microsoft Azure that will work across LiquidText on any of your devices on any platform.
Okay. So I guess really to sum up, I would like to ask you, do you have any advice? There may be a number of developers out there watching. They've got a new idea. They want to achieve wide platform availability. Have you got any advice you can give them about how to start, approach to take? Any little bits of LiquidText wisdom that you've built up along the way that they could benefit from?
Yeah, that's a really good question. And, this is kind of the thing that I struggled with a lot at the beginning. There's no silver bullet when it comes to cross-platform, right? There is no such thing as write once, run anywhere, and have great performance, and everything just, is magically the same and just works, right? If you want to work on an iPad and a UWP system, there's going to be trade-offs. There's going to be there's going to be questions, and there's going to be differences. And so you really need to start by understanding your users, right? You need to study your users. You need to study your users, know what their requirements are, on different devices. One of the things that we found is that what people need on one device is sometimes significantly different than what they need on a different device. Understand that carefully, and that'll help you understand what the right trade-offs are that you can make without sacrificing value for your end users. And from there, it kind of becomes a lot easier to back your way into a cross-platform strategy. But again, you just got to start with your users.
Okay, great. So, user experience, key thing there. So I think we're almost out of time. I'd like to give a big thanks to Craig for spending time with us today and sharing the insights that he's gained during his porting journey with LiquidText. I guess we should also say that if developers are interested or they think there's any significant porting enablers missing for their ARM porting journey, then by all means, please let us know. Hope that was useful, and thanks very much for watching.
Thank you so much.